Okay, so today we are going to discuss a NUST entry test past paper. So, question 1 says if 3, 5 is midpoint of 5a and b7, then okay, so for midpoint, we should know that let's say xy is midpoint of 2 points, then this is the formula which we use. All right. So basically, if we have been given with 2 points, let's say x1, y1 and x2, y2, and we need to find the midpoint that is xy, we do it this way. Similarly, in this question, our midpoint is 3, 5. So we can write it as 5 plus b by 2, comma a plus 7 by 2, because y1 is a and y2 is 7. And now obviously we have two ordered pairs, so we can compare the x parts. So 3 equals 5 plus b by 2 and 5 equals a plus 7 by 2. Now we simply have to simplify things. I can take this 2 here, I'll get 6 minus 5 equals b, and here I'll get 10 minus 7 equals a. So b is 1 and a is 3. So clearly D is the answer. All you need to do is apply the formulas. We know that this is the formula and this is the midpoint, and the 2 points which we have been given are 5a and b7. So the midpoint of 5a and b7 is 3, 5. We have this formula. We simply need to plug in our values in the formula. We got two equations, 1 and 2, and simply we can find a and b through this. Okay, perfect. Now let's just rub some part of it. All right, let's talk about the second question now. Okay. So for second question, the sum of odd coefficients in the expansion of 1 plus x to the 4. Okay, so 1 plus x to the 4. Let's just first expand it by using the binomial theorem. So think of it as 1 plus x to the n. This is the general form. In our case, n is 4. Now we are good to go. We simply need to apply the binomial theorem. So the binomial theorem says first term is 1 plus nx, our n is 4. So 4x would come plus the third term is n, that is 4, into n minus 1, that is 3, divided by 2 factorial x square plus the third term is n into n minus 1 into n minus 2 divided by 3 factorial into x cube, and the fourth term is n into n minus 1 into n minus 2 into n minus 3 divided by 4 factorial into x to the 4. Now we simply need to identify the odd terms, because here the question is to find the sum of odd coefficients, right? So we need to find the odd terms. So this is the first term, so this is the odd term. Then second term is 4x, third term is this, again this is the odd term. Then the coefficient of x cube is basically the fourth term, so we will not include it. And then this is the last term. Let's just simplify things. 2 factorial can be cancelled this way, and 4 factorial will cancel all this. So we have 1 plus 2 into 3 is 6 plus the coefficient of x to the 4, that is 1. So this is basically 8. So B is our answer. Again, for this question, like part 1, we need to know the formula. And here our formula is basically the binomial theorem, with the help of which we can easily calculate the coefficients, and we had to add the odd coefficients, and this is how we got 8. Okay. Now the third question says measure of the central angle of an arc of a circle whose length is equal to the radius of the circle is known as. Okay, now we need to understand the question, right? We need to find the central angle. Okay, so let's say if this is a circle with this center, then this angle, which is basically creating this arc, is the central angle. To find this arc, the formula is angle, central angle, divided by, you can either use 2 pi or 360. If you want your answer in radians, you need to use 2 pi. And if you want your answer in degrees, you need to use 360 degrees into. Now this is the arc length. So you need to write down the circumference of the circle equals. Now let's read the question, okay? But if you read the question as it is, initially students get confused. So the best thing is to read some part of the question, note down the data, use your formulas, and then read the rest of the part. So the question was measure of the central angle of an arc of a circle whose length is equal to radius. Arc length. Arc length. This is arc length equals radius, that is r, and we need to find the central angle. This is what we need to find. We need to find x, right? Okay, let's just simplify things. 2 pi and 2 pi would be cancelled, r and r would be cancelled, so we have x degree equals 1 radian. Our answer is in radian because, as I told you initially, we use 2 pi. If we use 2 pi, our central angle or x degrees is basically in radians. Okay, if you want to answer in degrees, we use 360 instead of 2 pi. Okay, now my answer is 1 radian, so B is the answer. Okay, perfect. Let's talk about the fourth question. Okay, all right. So fourth question is a circular wire of radius 3 centimeters is cut, straightened, and then bent so as to lie along the circumference of a hoop of radius 24 centimeters. Okay. So basically, this is a circle with radius 3 centimeters, and then this is a circle with radius 24 centimeters. This circle is opened up to wrap around a part of this bigger circle. Let's say this smaller circle is open and it is wrapped around this part. So we need to find this angle, okay? So we need to measure the angle subtended at the center of the hoop. Okay, perfect. So basically you have two circles, one circle with radius 3, the other circle with radius 24. The smaller circle is cut, straightened, and then bent along the bigger circle. And you need to find the angle which would basically be corresponding to this arc. Okay, again, we are going to talk about the arc length here. So x degrees divided by 2 pi, okay, into 2 pi r equals, now we know that the arc length of this part is basically the circumference of small circle. So circumference of a circle with radius 3 is 2 pi r, that is 6 pi. So the arc length is 6 pi, so we will write 6 pi here. And here we are talking about the big circle. So in r we will have 24. This implies x is pi by 4 radians. Okay. Now our answer is in degrees. We need to convert this into degrees. Okay. So if pi is 180, then pi by 4 is going to be 45 degrees. So this is the answer. So here basically we had two circles. One circle is basically straightened and then bent along the bigger circle, and the arc around which the smaller circle was bent, we need to find the angle that is corresponding to that arc, right? So this is basically the arc length formula. Obviously, the length of arc would be 6 pi. That is the circumference of the smaller circle. And by simply cancelling out everything, we got 45 degrees as an answer. Okay. Now, let's talk about the fifth question. Okay. So here we have, if Q, R are any sets, then Q minus R is, okay. Now, think of Q as a set, right? And then R is our second set. So Q has some part of R in it. And when we are saying Q minus R, we only have Q without that R part in Q. Okay, so we have Q only. Let's think about it as Q1. Okay, right. Okay. And now we need to know that which of the options is basically Q minus R. All right. So option A says Q intersection Q minus R. So whenever we have intersection, we only write down the common area, right? So Q intersection Q minus R says basically this would be Q1. Q1 is Q without R. And this is all the Q. But since this is intersection, we only need to write down the common area. So both these sets have Q1 because Q1 is the part of Q without R. And big Q, like this Q, has Q1 plus that R thing as well. So obviously, when we're talking about intersection, we just write down the common part. So the common part would be Q1, that is Q minus R. So clearly A is the answer. All right. Now let's talk about the sixth question. So here we have two complex numbers. Z is this 2 plus 7i divided by 2 minus 8i. And then we have this fraction, which is just like z, but the only difference is that both the in both the numerator and denominator, the imaginary part is being multiplied with minus. As in here we had plus 7i, here we have minus. Then in the denominator of z we have 2 minus 8i, and here we have 2 plus 8i. All right. Now we can see that this is what happens in case of conjugates, right? So clearly B is the answer. Now here Z is basically, Z conjugate is basically going to be the conjugate of the numerator and the conjugate of the denominator. So that is going to be the conjugate of 2 plus 7i is 2 minus 7i, and the conjugate of 2 minus 8i is going to be 2 plus 8i. So B is the answer. Okay. Now we have the seventh question. So for question 7, we know that if Z1 is 2 plus 6i and Z2 is 3 plus 7i, then which expression defines the products of Z1 and Z2? Okay. Now we need to multiply Z1 and Z2. And we know that these are two complex numbers. Okay. So we need to multiply both of these. So first we'll multiply 2 with 3. We'll get 6 plus 2 into 7i, that is 14i, plus 6i into 3, that is 18i, plus iota square into 42, that is 6 into 7. Now we need to simplify. Okay, so this is 6 plus 14 plus 18 is 32i, and iota square is minus 42. So 6 minus 42 is basically minus 36 plus 32i. So B is the answer, right? So this was an easy question. But in any T, obviously the questions would be of mixed difficulty level, as in the difficulty level would vary from question to question. Some questions would be very easy, You would be able to do it in a minute or so, and then you'll have questions for which you'll be spending 5 minutes or so, right? So you need to be very careful when when it comes to the allocation of time. All right. So let's talk about the eighth question now. Which of the following has the same value as I to the 113? Okay. So it is I to the 113. Now, if we think of this 113 itself, the question looks very different, right? But let's just talk about that I square is -1, right? Okay. So we know that I square is -1, and we can break down this I to the 113 as I 112 into I did this because I know that I squared is equal to -1, right? So I can write this I to the 113 as I to the 112 into I, because when bases are same, in this case base is I, the powers are added. One power is 112 and the other power is I. So this is going to be 113, right? It was just an explanation to tell you that how I wrote this. Okay. So now we have I to the 112, and I can write it as I square to the 56 into I. Why am I doing it? You will just get to know. I square is -1. We know this through here. -1 to the 56 into I. Now, whenever we have -1 to the to the even power, let's say if we have -1 to the square, -1 to the 4, -1 to the 50, any even power would make -1 positive number. So we have 1 into I, that is I. So A is the answer, right? So if you come across such questions, first you have to break it down such that you get even power. Once you have even power, you can split that even power by dividing that power to 2. So 112 can be written as 56 into 2. Why did I do this? Because I know that I square is -1. All right, so we are done with this part as well. Let's talk about the ninth question now. The area of a sector with central angle 0.5 radians in a circular region whose radius 2m. Okay. Now we need to find the area. Okay. So we need to do x degrees divided by 2 pi into pi r square. Pi and pi can be cancelled. X degrees is 0.5, that is given, divided by 2 into 2 square, radius square. So this is going to be 1 by 2 into 2, that is 1 meter square, because the radius is in meters. So D is the answer, right? Okay. Okay, so now we have the 10th question. The maximum value of sin x plus cos x is, so we know that in case of sin x, the graph goes like this. So this is 1 because we have sin x, and this is -1. We have sin x here and x here. So clearly the maximum value of sin is 1. And if we talk about cos, again the maximum value is 1 and the minimum value is -1, right? This is how the graph of cos is. So in order to find the maximum of sin x plus cos x, we need to know the maximum of sin x plus the maximum of cos x. And by looking at these two graphs, we know that maximum of sin x is 1 and maximum of cos x is also 1. So this is 2. So B is the answer. Okay. All right, now we have the 11th question. The center of the circle, this is. Now this is the equation of circle. Although it doesn't look like the equation of a circle, but we'll make it look like the equation of a circle, and then we would be able to find out the center points. Okay. So what we can do is we can write 5x square plus 24x equals minus 5y square minus 36y minus 10, right? So I've taken all the y parts and 10 to the right hand side. I can take 5 common and I'll get x square plus 24 by 5. Now I need to complete the square. So this is basically 2ab. So b would be 24 by 10. In NET, you would not be allowed to use the calculator. So we will be doing it without calculator. Square equals, now I'll take minus 5 common. So I'll get y square minus 36, sorry, plus 36 by 5 y plus 2. Okay. So this is 5 x plus 2.4 square minus 2.4 square, and we have minus 5 y square plus 36 by 5y plus, again I need to add and subtract b square. So in this case it would be 3.6 square minus 3.6 square plus 2. So this 5 and this 5 can be cancelled. I will get x plus 2.4 whole square plus y plus 3.6 whole square equals 2.4 square minus 3.6 square plus 10 and stuff like that. But we are not concerned about this part, okay? So do not waste your time in calculating all this. And this is why they ask you such questions in NET which you are able to do without calculator, right? You would not be able to calculate all this without calculator. I mean, it's just going to take a lot of time and we do not even need it. So what we need is the center. The general form is x minus a square plus x y minus b square, and so a and b is the center. In our case, we have x plus 2.4, so I can write it as x minus 2.4 and then whole square plus y minus 3.6 whole square. So in short, since we had plus and plus here, our x coordinate of the center would be minus 2.4 and y coordinate of the center would be minus 3.6. So this is the answer, right? So here, initially, the equation of circle did not look like the one which we are used to dealing with. So the only task in this question was to make the equation look like the equation of circle. Once we have the equation of circle, we know how to find out the center coordinates, right? So in the general form, we have x minus a and y minus b. And here initially we got x plus 2.4 and y plus 3.6. So since in the general form we have minus sign, we will take x minus 2.4, right? All right. So we are done with this part. Now let's talk about the second last question. Here we need to find 1 by 2 plus iota under root 3 2 to the 6. Okay. So I can write it as, since this way it would be very difficult. So I can write it as 1 by 2 plus iota under root 3 by 2 to the square into 1 by 2 iota under root 3 by 2 to the square into 1 by 2 plus iota under root 3 by 2 square. Now when bases are same, powers are added. I've written this whole thing 3 times with 2 as the power because this is equal to 1 by 2 plus iota under root 3 by 2 to the 6, right? And I can find it out easily, but I cannot find this out. Okay, so let's find 1 by 2 plus iota under root 3 by 2 to the square. All right, so we know that we will have 1 by 2 into 1 by 2 plus iota under root 3 by 4 plus we are going to get this is how I'm multiplying it because we just have to multiply it initially and all the other factors would be multiplied in similar way. Okay, so 1 by 2 into 1 by 2 is this, then 1 by 2 into this part is this, plus again we will get 1 by 4 iota under root 3, and then we will have plus iota square under root 3 square by 4. So here this and this would be cancelled, and if I simplify I will get 1 by 4 plus iota under root 3 by 2 because we have it twice minus 3 by 4. So this is basically minus 1 by 2 plus iota under root 3 by 2. Now this is basically one of these factors and I need to multiply it with itself and then the answer with this factor again. Okay. So we will get minus 1 by 2 plus iota under root 3 by 2 into minus 1 by 2 plus iota under root 3 by 2. I will get 1 by 4 minus iota under root 3 by 4 minus iota under root 3 by 4 minus 3 by 4. So I will get 1 by 2 minus 1 by 2 minus iota under root 3 by 4. Okay. And now I need to multiply this with this because this minus 1 by 2 minus iota under root 3 by 4 is basically the value of these two. And I need this. I will multiply this with this. And I already got this through here. This is basically this. Okay. So I have to multiply this with this. All right. Now we can see that this is basically a square minus b square because this is a minus b and a plus b. So a square is 1 by 4 minus b square is this. So I will get 1 by 4 plus 3 by 4 because iota square is minus 1 and I'll finally get 1. So 1 is the answer here. 1 is the answer. Okay. So for such a question, just understand that if this is 6, you cannot do it directly. You can just do it if you have the power 2. But you know that you can break this 6 into 2, 2 and 2, because when your bases are same, your powers would be added. Okay, so this is basically this. Now first step is to find this. We calculated 1 by 2 plus iota under root 3 by 2, and we got this as our answer. And once we had this, once we had 1, we will simply multiply it 3 times, because this 1 is this and this, right? We'll multiply it 3 times, and we multiplied it 3 times, and in the final step we got a minus b, a plus b type, that is basically a square minus b square, and then we got 1 by 4 minus iota squared 3 by 4. Since we have iota squared, this would become plus, and our value would be 1, right? So we are done with this question as well. Okay. All right. Now we have the modulus of the complex number. Now here we have a complex number. We're talking about its mod. Whenever we have a complex number, let's say we have a plus b iota, the mod of this number is basically the real square, that is a square, plus complex square, that is b square, right? So we need to square the real parts and the imaginary parts. Okay. So here the real part is 1, a is 1, and b is tan alpha. So under root a square plus b square is tan square alpha, and that is basically secant square alpha under root. So I can cancel these out and I will get this as the answer, because I know that 1 plus tan square alpha is secant square alpha. This is a trigonometric identity which you should know, and by using this we can simply do this. Okay, so the only tip I would like to give today is that we had difficult calculations, and in NET we are not allowed to use the calculator. So never ever think by looking at the question that you would not be able to do it without calculator. If you're thinking that, just know that you're going in the wrong direction, because like in few questions where where the calculations were getting very difficult, like this question, but we were only concerned with the simple part. We were only concerned with finding the center, right? So you should know that even the question looks difficult, even if it looks difficult, you would be able to do it without calculator, because these questions are designed this way. Okay, so yes, that's it for today.